Hi everyone, good day. Welcome to VSPARKZ channel. Today I'm going to walk you through AWS NAT Gateways, its concepts, characteristics and a demo. If you like this video, please subscribe to VSPARKZ channel. This is the agenda of this video. We are going to see what is NAT with an example. Then we are going to see AWS NAT Gateways and at last the demo. These are the things that we are going to see in this demo. Let us first discuss what is NAT. NAT stands for Network Address Translation. That is a method of mapping one IP address into another. This translation is done by the routing or NAT device. In this technique, usually the private addresses are translated or mapped into a public addresses. Once translated, the source addresses appears to be the public address and not the internal private IP addresses. Thereby, we are hiding the private IP host to the outside world with the help of public IP. Let us see the concept of NAT with an example. In this example, you can see the internal IP ranges, that is 172.19.1.x. So that range of IP address is assigned to 3 computers and it is NATed with the help of a router and a public IP address. So the people in the internet cannot see or access the private range of IPs here. I mean, no one can see these computers here. But whereas the devices or the computers here with the private IP addresses can access the internet with the help of NAT technique. Let us see what is AWS NAT. Actually, AWS offers 2 types of NAT techniques. One is NAT instance and the second is NAT gateways. You can accomplish this NAT technique with the help of these 2 services. In this video, we are going to cover NAT gateway only. Let us see the characteristics of a NAT gateway. A NAT gateway can support up to 5 Gbps of bandwidth and it can scale up to 45 Gbps. You can associate exactly one IP addresses, that is the elastic IP address, with a NAT gateway. A NAT gateway can support up to 55,000 simultaneous connections to each unique destinations. A NAT gateway supports the following protocols. So this NAT gateway supports TCP, UDP and ICMP. You can also use a network ACL to control the traffic to and fro from the subnet in which the NAT gateway is located, but you cannot control the traffic flow from or within NAT gateways. Let us discuss the same thing with an architecture of how this NAT works, how we can connect the internal IP addresses from outside. So this is the exact architecture of AWS NAT Gateway. You can see a VPC with one public subnet and one private subnet. The private EC2 machines in the private subnet cannot access the internet for any online upgrades, patching, download, etc. since they don't have any public IP addresses. So the private EC2 machines are highlighted with a green color. So one of the solutions to this problem is NAT Gateway, which needs to get deployed in the public subnet. So this NAT gateway is associated with an elastic IP address. Now, after deploying this NAT gateways, the instances in the private subnet, I mean the highlighted machines, the green color, can reach the internet with the help of NAT gateway, provided the route tables for each subnet should get updated accordingly. Let us see the demo. Here are the things that we are going to see in this demo. The first step, we are going to create a VPC and an internet gateway. Second step, we are going to create a public subnet and a private subnet. Third step, we are going to create and update route table for the public subnets. Fourth steps, we are going to deploy machines in those two subnets. Fifth step, we are going to create a NAT gateway in public subnet. Sixth step, we are going to update the route tables for the private subnets. And at last, we are going to test the connection. This is the first step of our architecture. We are going to create a VPC and an internet gateway. So just log into your AWS Management Console, hit Services, go to VPC, create a new VPC and an internet gateway. So I am going to use the exact CIDR range which was given in the architecture diagram. Click Create VPC, give a name tag, and the CIDR range which I was using in the architecture is 172.19.0.0/16. So now my VPC got created. The next thing is I'm going to create an internet gateway. That's it. My internet gateway is created. Just attach it to your VPC. We are done with our first steps. This is how your architecture looks like once you are done with your first step. This is your second step. So in the second step, we are going to create a public subnet and a private subnet within that VPC. I am going to use one availability zone for those two subnets. Just go to subnets, just click create subnet, give a name tag for your subnet. So now I am going to create a public subnet. The CIDR block which I am going to use is 172.19.1.0/24. So to make it as a public subnet, we are going to change one parameter, that is your auto assign IPv4 parameter. You have to set it as yes to make it as a public subnet. Thereby the machines that you deploy in this subnet will be getting a public IP address. So the next thing is I am going to create a private subnet. By default, the subnets that you are creating in your VPC console will be the private subnets. The CIDR range that I am going to use for my private subnet is 172.19.2.0/24. So now my private and public subnets are created as per the diagram. The third step, I am going to create the route table for my public subnet. So by default, one main route table will be there, once you create your VPC. But we are not going to use the main route table. Instead, we are going to customize our route table by creating a new one. So I am going to create a route table for my public subnet. So once you create your route table, you have to associate that route table with your subnets. So this route table is intended for my public subnet. So I have to associate this route table only with the public subnet. Go to routes, edit routes, add a route, give the all public route here, that is 0.0.0/0, and your target should be Internet Gateway. The Internet Gateway which we were already created, you have to mention that one here. So now our architecture looks like this. As a first step, we are going to deploy machines in those two subnets. So for time being, I am using another tab for my comfort. Just go to EC2 console, deploy your EC2 machines in private subnet as well as in the public subnet. So I am going to use a Windows server machine here. So if you are going or practicing with your free trial account, try to choose only the free trial AMIs. So now I am using my public subnet to deploy the first machine. Time being, I am allowing all the traffic here. So now my first machine got deployed in my public subnet. So once you deploy your machine, don't forget to tag it. So this is easy when you are deploying multiple machines in your console. So now my public machine got deployed and it has a public IP as well as a private IP. So we have to wait for at least 4 minutes as per AWS to log into the machine. So now I am going to deploy my second machine in the private subnet. I am going to use the existing security group, click launch. I have this key already with my local computer. Now my second machine got deployed in the private subnet, which means this machine will be having only the private IP address. So now I am connecting on public machine. So to get your credentials, use the key to decrypt your password. Now my username and password is visible in the window. Use the same in your client. So I am using the remote desktop client for Windows. If you are going to use a Linux machine, try to use a Linux client or a SSH client like PuTTY Mobile Exterm. Now from the internet I connected my public machine. Try to check whether you got internet connectivity in this machine. You will be having internet connectivity since this is a public machine. Now try to connect the private machine within the public machine, because the public machine and my private machine shares the same network, I mean the VPC. So if you want to connect the private machine, you have to log into the public machine and then you have to log in to the private machine. Directly you cannot log into the private machine since it does not have a public IP address. So from your public machine you can reach your private machine with the help of the private IP address. Why? Because both the machines are in the same VPC. Try to decode the password as we did for your public machines. So now I got connected to my private machine. Just try to check whether it has got public internet connectivity or not. Just try to ping google.com. It will not ping google.com since this machine is not connected to the internet as it does not have a public IP address. And one such solution to enable internet connectivity is the NAT Gateway. So now we are going to deploy the NAT Gateway in the public subnet so as to enable access to our private subnets. So now just go to your VPC console, hit NAT Gateways, create a NAT Gateway. You remember the NAT Gateway should get created in the public subnet. Just hit create a new EIP, elastic IP address. Now my NAT Gateway got created in the public subnet. It will take some time for the NAT Gateway to become active. Once this has been created, you have to update the route tables in both private and the public subnets. So my sixth step is to update the route tables for the private subnet. So we have to include the public route there and you have to mention the target as the NAT Gateway. Thereby the machines in the public subnet reaches the NAT Gateway, NATing happens there and then it will reach the internet. Now we are creating a route table for your private subnet. So once you create your route table, you have to associate the same to your private subnets. So we got only one private subnet, you have to associate that private subnet to this route table. If you have multiple subnets here, you have to associate all the subnets to this route table. Add a route, give the all public route here and the target to get set as NAT Gateway. So now we have updated the route table as per your configurations. Now we need to test the connection. Let's go to your private machine. Just hit ping google.com. Just wait for a while and then try again. Yeah, we are getting responses from google.com within your private machine. So this private machine has got internet connectivity now. Here is the summary of our video. We have seen what is network address translation with an example and its characteristics of AWS NAT gateways, and at last we have seen a demo. So these are the things that we have seen in this demo with the step-by-step architectures. That's it. We come to the end of this demo. If you like this video, please subscribe to VSPARKZ channel. Thank you from VSPARKZ.com for spending your valuable time and seeing this video. Have a good day ahead.